consider design for success. So design for success should be, we should build the software in keeping in mind with future changes, scalability or maintenance in mind. We should keep well record, clear and updated documentation. And we should plan for second opinion, regularly code reviewing, peer reviewing with the internal or external experts actually. So the design for success, actually, the thing is that it is designed for change. So in the design for change, the principle is known by various names. The code is ongoing still. Okay. So in the design for success, actually the thing is related with our actually mindset. The first one is, and that we need to very much adaptable with the requirements. We need to maintainable with the changes. Even we need to robust in the updating cases. So there are some principle. Those are very much related with the principle of success. That is, say, information hiding, abstraction, separation of concern. Some are data hiding and object orientation. So it might have that we could hide some internal implementation and details so that we can change later when it's necessary without affecting the other parts of the system. And even for the abstraction, so we need to expose those parts. Those are actually those are relevant feature to us, and we can hide the complexity also. Okay. And if my screen is paused. Even separation of concern, so we can break the system into distinct sections. Even we can handle those specific responsibilities. So these are different technique that if we actually anticipate in advance what are those features can come later, so we can implement or we can hide those, but still the system in use. But when we need to update those, we can make it with comfort without affecting the service of other modules. To apply this principle, one begins by trying to characterize the changes that are likely to occur over the lifetime of product. Since the actual change cannot be predicted, yes, it's very obvious. It's very difficult to change, but we can make some classes. We can make some segments that where we should make some changes, maybe changes in the UI, maybe changing the data representation, or changing the operating system. So we can anticipate in advance. So since it is impossible to make everything equally easy to change, it is important to estimate the probabilities of how the change will actually appear, and organize the software so that items that are more likely to change are confined to a small amount of code actually. Yeah, design for change is ignored because we do not have any precise rules or technique in any books or in the training. And programmers are impatient because they try to make their launch their product. So designs that result from the principle are different. Yeah, and that we are the design of change. These are difficult than the natural design that we make. So why in the design for change is ignored again? If we say that a few good examples of the application of the principle, designers tend to mimic other designers they have seen. So it might make the system more worse because, say, we are mimicking one design of a programmer, but that the design is bad, poor. So we will actually iterate or repeat the same problem. Okay. So programmers actually tend to confuse design principle with the language. So it's a very big issue. So we actually confuse with the design pattern and with the language. Though we are telling that we are using object-oriented program, still we are creating object, but we are doing program like procedural programs. Yeah, this is true because these are actually a lack of original training. So these are actually, so people say that they are using Java or Python, but they are not introducing any abstractions or separation of concern, or even there is no data accessing mechanism or no interfacing. So and these are true. So keeping records, yeah, even when software is well designed, it is not often documented. So when the software documentation is present, it is often poorly organized. They are inconsistent, they're incomplete, and even sometimes it is true that people write documentation, but they do not understand anything regarding the anything. Okay, so it might happen. So documentation is sometimes is ignored, strongly ignored by the maintainers. So ORS documentation is ignored by managers because it does not speed up the initial release. So some of these managers are also, they feel in the same way. So this is another preventive measurement for software aging. That is, we need to introduce some, we should review the actually codes. So in engineering or medicine is this, if we have a review, so there might be a question, but in software engineering is that we must have this peer reviewing thing. So every design should be reviewed or approved by someone whose responsibilities are from the long-term future of the product. So we must review our products. This could be one preventive action. Yes, after doing all these things, so it's very much likely that still software aging will happen. So if we still do this thing, if we think that we can protect or we can encounter the software aging, then we should say that we are dreaming actually. So our ability to design for change depends on the ability to predict the future. Definitely, we must anticipate the long distant future. So changes that are violate original assumption can also be made over the period of years. Documentation is never perfect, and reviews are bound to miss flaws. Sometimes reviewers are not done. So preventive measures are worthwhile, is it? But anyone who thinks that we can eliminate aging, so this is not practical. So software geriatrics, like human health, software geriatrics is well used. So in software geriatrics, a major steps, there are two different steps that are retroactive documentation and there is retroactive modularization. So retroactive means we can think from the past. So in major step for understanding the software health to limit the software aging or restrict the software aging, major step is slowing the age of older software, often reviving it and to upgrade the quality of the documentation. And even we can change the structure so that each module hides a design decision that are likely to change. We have already discussed about the design for change section that we might need to hide some abstraction. If those are required, we can use that time. But if it's not required, might later make it visible when it is necessary. So in software geriatrics, other two other case amputation, and another one is major surgery. So in the amputation is a section of a code has been modified so often, is changed so often. For example, in one e-commerce project application, say discount section might be changed a lot of time, so thoughtlessly. So this is not worth saving. Rather, we discard it and write later it from the scratch. And in the major surgery, we can find that we can restructure it by re-engineering in that part. So it might happen that in some of our system, some features are overlapping. So what can we do? Maybe in a logistics system. In a logistics system, there are many features, and those are reusable. So what can we do? We can make one clean version, and we can reduce the overlapping by the different components. So it's time to, we should plan ahead. So we should stop our this mindset, getting it to run. Only we have this mindset actually. Our target is let's run it first. Then it will, what will happen, we'll embrace. But if this is the case, so it will definitely lose its long-term sustainability. So design and change have to be well documented and carefully reviewed. If it is not documented, we will say that it is not done to combat with the software aging. The same should be actually in the other areas that engineering product obsolescence is recognized and included. So in other area of engineering, maybe in civil engineering or mechanical engineering, that if something is obsolete, they actually recognize it. So we should do the same thing in the software engineering. So now come to the working with the legacy system. So in the legacy system, is just not it's not just actually old code. They are actually deeply connected with different component of the system. So many software systems that are still in use or developed so many years ago, but they are now obsolete. This system has many business rules, business policies. So, and that's why they are given name as a legacy system. So in the legacy system and the replacement, there is a replacement is not actually so easy because there is a so much business risk. Only the scrapping the legacy system and replacing with the other system, it could be doable. It is doable, but it is not actually recommended because legacy system rarely have a it's have actually complete different specification or different requirement. So it has different business process, and the system may have some business rules or strategies. So new software development is risky, and those are not might be successful. So however, the changing legacy system is often actually expensive because different parts implemented by different teams and it has no documentation. So how it could be they follow the consistent programming style, and even the system has some obsolete programming actually things, say maybe COBOL or Fortran, and the system structure may be corrupted by many years ago, and the file structure may be incorporated. Maybe they have used other database or even maybe a simple file system. So yes, legacy is a dilemma. So sometimes we are telling that yeah, legacy is expensive and risky, and sometimes say that yes, legacy system it is not performing well. So we should actually uh, should perform the action in a way. Actually, this thing could be balanced, and it's give the highest performance, highest resultant value. The legacy system structure, it is called that it was a socio-technical system, not a simple system. Why it is telling so? Because it is not only technical component, it might have software, hardware, network, but it has a social component also. It might have people, process, teams, workflow. So, and that's why and this legacy system is called is a socio-technical system. So we have application data, we have hardware, software, business process, objectives, so many things. So here we can see this is different components of the legacy system. Though it starts actually from system hardware because hardware actually run the support. This was the thing, support software. So after the support software, we actually run our application software. In the application software, we use different data, and we use different business process. Later, our system inform us. So this is so embedding the knowledge from the business rules and policies, and this inform how the actually application behaves. Also, we give some constraint. So this is the layered approach of socio-technical system. First hardware, software application, software, and the business processes that I have mentioned. System change, in principle, it should be possible to replace. In ideal cases, we are thinking that it is possible because the system, the module had a layered approach. But the thing is not this, not in actually practical situation, because if one layer has some specific output or compatibility, if we change that layer, it not may be suitable for the just immediate the above layer. So changing the software may slow down it. So changing hardware may also require. It is often impossible to maintain the hardware because it has different interfaces. So these interfaces might be different for the mainframe computer or maybe client for server systems. So here we can see that one legacy system specific application. There are some programs and there are some files. So different programs are accessing to the same file, or same program might be used by the different. So it has maybe high coupling, tight coupling. Even it has some complex data sharing structure. So it's very hard to understand and to maintain because it has a flat file system or might be some other database system. So in our, we can see that in our transaction, in the transaction processing thing, we can see that there are some other components. One is the terminal, and the second one is teleprocessing monitoring. So the teleprocessing monitoring, actually it was used in the legacy system, especially in the banking cases, banking situation. Multiple users simultaneously, if they want to access those teleprocessing monitor, they actually played crucial roles in the banking system. And then they use the serialized transaction. We know serialized transaction means if some customer requesting a transaction in the order, they have to send the order into the in their database. So there are some order of the request and the processing of data. So these are actually the serialized transactions. So in the legacy system, the system might be filed with based on the incompatible files. They might be use DBMS system, but those DBMS system actually not suitable with the maybe teleprocessing monitor system. Okay, so there are so many issues, because in if we say that we have different types of database in recent time, so maybe Oracle, say MySQL, or Postgres MySQL. So there are some other. Sometimes we find, though now we know how to those are make compatible, but if we have some legacy system, maybe 60s or 90s, those might be not compatible to get those data. So most legacy systems are designed before object-oriented development thing. So that time, rather than being organized as a set of interacting objects, those time we use simple functions or routines. So there are some other issues. So if we can see that so this is a functional oriented view of a design. So in the functional oriented view, we can see that that we have the structure as a set of interacting functions, function F1, F2, F5. So this function actually they share or access to the same data space, that is shared memory. So these are challenging. Even in the functional processing design, we have some other issues that are centralized, and the data is stored in one place, and they have tight coupling. Tight coupling means functions are highly interdependent. If you change the structure of a shared data, and the many functions may be updated. So I think these are related with different other applications. You can you can just go through this. So this is given one example for data flow diagram of payroll system. So the idea is that here you can see that okay, sorry. So if we can say that we have some other system has some business values, we have some other system has system quality. So if we organize those in a way, if we make some trade-off, we can see this parable actually, it has high business value but low quality. So it has low business value and low quality. It has maybe low business value and high quality, and it has high business value and high quality. So it's necessary that for our legacy system, how we will actually interact with this legacy system. If our system is low quality and low business value, we must have to scrap those system. If we have the system has a low technical quality but high business value, then this make an important business contribution but are expensive to maintain. Yeah, then we should re-engineer, replace some of the components to revive or rejuvenate our legacy system. But if we have high quality of technical but low business value, then we can actually scrap completely. We replace with the change of the technical system. And if we have high technical quality but and high business value, so definitely we can continue with this thing, though it's an old system, but still it's performing well. So there are some ways how we can actually assess the business values. That's for assessment of business value, we should assess the system end users. We should actually make some survey of business customers, line managers, some other things for assessing the business values. For system quality assessment, we need to check the business process, even the environment, how those are effective, even the quality of the application of the software. So these are the different environment assessment. So the key points that we've discussed today. So a legacy system is an old system that is still provides essential business services, yes. And legacy system are not just application software, but it includes the business rules, policies, and hardware. So most legacy systems are made of several different programs and shared data. This should be function oriented. So the structure of the legacy business system normally follow up an input process and output model, and the business value should reflect the system's effectiveness. So these are actually our key value, and we have to keep in mind if one system got aged, And after when it is get aged, it actually turns into a system that is kind of legacy system. So we should check the cost. Now, what are the cost and how to actually limit the effect of the legacy system, and how long we can extend, though it is old system, still we can give service with low resource consumption and making it big business value. And this is why this is very important discussion. So I think that's all today. And we'll discuss further if we have more class.